Today we're talking all about scientists confirming the first black hole ever imaged is actually spinning, and how researchers developed 3D printed sensors that can record brain activity on earbuds. Let's start off spinning. The first black hole humanity has ever imaged has also provided us with what researchers are calling unequivocal evidence that black holes spin. An international team of scientists headed by Chinese researcher Dr. Qiyu Zhu analyzed 22 years of observational data gathered by more than 20 telescopes around the world. What they found was that the black hole at the center of galaxy M87, which is 6.5 billion times more massive than our sun, by the way, exhibits an oscillating jet that swings up and down every 11 years. This phenomenon confirms that the black hole is indeed spinning. Black holes gobble up huge amounts of gas and dust, which they attract with their massive gravitational pull. A small fraction of those particles that don't fall into the black hole get spewed out and travel close to the speed of light, showing up as narrow beams along the axis. These beams are called jets. The telescope's observations show that M87's jet oscillates by 10 degrees in a recurring 11-year cycle, just as predicted by Einstein's general theory of relativity. So what causes M87's jet to swing back and forth? The researchers' analysis indicates that the black hole spin axis doesn't perfectly align with the rotational axis of its accretion disk. This disk-like structure is typically found surrounding a black hole because it's made of materials that gradually spiral into the void to be consumed. That misalignment between the rotating mass and the matter that swirls around it causes a significant impact on surrounding spacetime, which affects the movement of nearby objects in what the general theory of relativity calls frame dragging. This is a significant discovery that massively improves our understanding of the mysterious region of space-time. Aside from proving Einstein right, of course, scientists have yet to find out the size of M87's accretion disk and how fast its black hole is spinning, though, and that entails further observation and analysis. Speaking of further observation and analysis, researchers at the University of California, San Diego have figured out a way to turn everyday earbuds into high-tech gadgets that can record electrical activity inside the brain. The 3D screen-printed flexible sensors are not only able to detect electrophysiological activity coming from the brain, but they can also harvest sweat. Yes, sweat. More specifically, sweat lactate, which is an organic acid that the body produces during exercise and normal metabolic activity. Because the ear contains sweat glands and is anatomically adjacent to the brain, earbuds are an ideal tool to gather this kind of data. You may be wondering why scientists are interested in collecting biometric info about brain activity at the intersection of human sweat. Together, EEG and sweat lactate data can be used to diagnose different types of seizures. There are more than 30 different types of recorded seizures, which are categorized differently according to the areas of the brain that are impacted during an event. But even beyond diagnostics, these variables can be helpful if you want to get a better picture of personal performance during exercise. Additionally, these biometric data points can be used to monitor stress and focus levels. And while in-ear sensing of biometric data is not a new innovation, the sensor technology is unique in that it can measure both brain activity and lactate. However, what's more important is that the researchers believe with more refinement and development, we will eventually see more wearables that use neuroimaging sensors like the one being made to collect health data on everyday devices. In a statement, UC San Diego bioengineering professor Gert Kauenberg said that being able to measure the dynamics of both brain cognitive activity and body metabolic state in one in-ear integrated device can open up tremendous opportunities for everyday health monitoring. Throughout the development of the sensor technology, the researchers had to grapple with some obstacles. They needed to make the sensors as small and thin as possible so that they could collect tiny sweat samples. According to Ernesto de la Paz, a PhD alumnus who co-authored the research, they also had to integrate components that can bend to account for the irregular shape of the ear. One primary technical challenge was being able to fit the sensors in the ear, specifically in the tragus of the ear, which is an anatomically unique space situated in front of the ear canal that can vary from one individual to another. This led the researchers to create a stamp-like stretchable sensor, which can be easily tacked onto an earbud surface. But in order to make sure that the sensors would actually have direct contact with the ear and accurately pick up readings, researchers opted for 3D printed spring-loaded sensors that hold contact but can adjust as earbuds move. The biometric sensors also had to be covered with a hydrogel film that made sure they would amply collect sweat from a wearer. Despite their capabilities and rosy future as a potential diagnostic aid, the 3D printed sensors really need a considerable amount of sweat in order to be useful for data analysis. But the researcher said down the line the sensors will be more precise, so hard workouts may not be necessary for meaningful sweat analysis. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributors Mariella Moon and Malak Saleh and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.